So students, earlier I was discussing about the spherical mirror. There are two types of spherical mirror. One is concave mirror, another is convex mirror. This point is called center of curvature. This point is called pole. Here this is pole. This is center of curvature. Okay. This is pole is the center point of this mirror. Here center point of this mirror is called pole. So this distance is radius of curvature. This axis is called principal axis. This axis is called principal axis. Okay, this axis is called principal axis. So this is center of curvature. This distance is radius of curvature. We have earlier learned about it. Okay. So suppose a ray parallel with the principal axis falls in this concave lens. So after reflection, it will go like this from this point. Suppose another ray parallel with the principal axis. This is principal axis. This is the incident ray. After falling, reflecting the concave mirror, it will go like this. So all the rays that are parallel with the principal axis initially, after reflection from the mirror, will go through a particular point. This point is called focal point. F is a focal point. Okay. Here, this is the incident ray parallel with this is principal axis. Okay. After reflection, this ray will go in this direction. It will not go this direction. In my previous video, I have made a mistake and shown that in convex lens, convex mirror, the reflecting ray will go like this. No, this is wrong. After reflection, this is incident ray, this is reflecting ray. Here also this is incident ray. This incident ray is parallel with the principal axis. This is principal axis. Okay. After reflection, it will go like this. So here you can see the difference clearly. Here all the reflected rays are meeting at this focal point. So here the rays are converging to a particular point. Here initially the rays that are parallel with the principal axis, after reflection, go away from the principal axis. This is the principal axis. So it is not moving towards the principal axis. It is going away from the principal axis. So this is diverging the incident ray. Here it is converging the incident ray. So the function of these two mirror are different. One is converging the incident ray, another is diverging the incident ray. Okay. So, uh, so these two rays, reflected rays, are not meeting at particular uh, point. Here the reflected rays are meeting at particular point, that is point F. So here it is not possible for the reflected rays to meet at particular point because they are diverging in nature. One is this direction, another is this direction. So how to get the focal point? If we extend this reflected ray back side, then I will get the point, focal point. It is appear to meet at point F. Actually these are not meeting at point A. Here it is meeting at point F, but here it is appear to meet at point F. So here this is focal point, here this is focal point. You can see in concave mirror the focal point and center of curvature at the left side, at the front of the mirror, but here the focal point and center of curvature are present behind the mirror at the back side. Okay, just behind the mirror at the right side. It is at the front side of the mirror, focal point and center of curvature. Here it is behind the mirror. So I will now discuss how the images are formed in these mirrors. So case 1 for concave mirror. Suppose this is the concave mirror. This is principal axis. This point is pole. This is focal point. This is center of curvature. Suppose an object is present at infinity. Object is at infinity. Okay. So all the rays will be here parallel with the principal ray. This is a parallel ray. So after reflection it will go through the focal point. This is a parallel ray. After reflection it go from the focal point. Okay, all the rays. So image will be formed at the focal point. So what is the nature of this image? We can write when object is at infinity. Okay. So nature of this image, I can write first. The image will be formed at, where the image will be formed? At F, at focal point, at F first. Second point, it is a very small image. The size of the image will be very small. So it is called highly diminished. Diminished means highly diminished. It is not diminished. It is just opposite of magnification, magnified or enlarged. So it is called highly diminished. Third is it is an real image because all the reflected rays are actually meeting at this point. Here you can say actually meeting at this point. These are not meeting behind the, we don't have to get points by extending the reflected ray. Okay, here actually the reflected rays are meeting. You can see all the reflected rays are meeting, so it is real. And here the image will be inverted. I have discussed what is erect and inverted. If this is an object, this is an image, this is inverted image, this is erect, this is called inverted. The top part of the object, in case of image, it is at the bottom, so it is inverted. This is erect. Okay, so this is the first case. So image will be really real. It is highly diminished at the focal point it will form, and it is an inverted image, and it is a real image. So case 2. In case 2, this is pole, this is focal point, this is C. Suppose beyond C, suppose this is point C, the object is kept here just beyond C. This is point C, this is focal point. Okay, this is pole, this is principal axis. So object, so the incident rays falling parallel with the principal axis, it will go just like that. Okay, so another ray is going through the focus. So it will go parallel in this direction. Suppose here the incident ray is parallel with the principal axis, so after reflection it will go through the focal point. So similarly, if an ray comes, incident ray comes through the focal point, after reflection it will be parallel. Okay, it is the incident ray is going through the focal point, so after reflection it will be parallel. Initially the incident ray is here parallel with the principal axis, and the reflected ray is going through the focal point, and here the incident ray is going through the focal point and the reflected ray is parallel with the principal axis. Okay, so these two rays will meet at this point. This is C. So within C and F, so where the position is within or between C and F. If object is beyond C, this is C, so it is just beyond C, so the image will be formed within C and F. Okay, 2. It is slightly smaller than the object. So it is called diminished. Previous it was called highly diminished. Here it is called diminished. It will be smaller than the object. So it is called diminished. Third, it is a real image because rays are meeting, reflected rays are meeting. So it is real image, and fourth, it is inverted. Okay, so this is case 2, when object is just beyond C. So image will be formed between C and F. It is slightly diminished. Okay, and it is a real image and it is inverted image. So third case, this is pole, this is F, this is C. Okay, suppose image object is at C. Here this is case 3. Okay, so here this is object at when at C, image will be at also C. This is same size. Object and image size is same here. Okay, here it is an real image and it is an inverted image. Okay, this is case 3, when the object is at C. Now object is between C and F. This is P, this is F, this is C. So object is now at between C and F. This is incident ray, this is okay. This is incident ray, this is reflected ray going through the focus. This is object, and here this is another incident ray and this is reflected ray. So here this point is C, and see this is image. So here image will be found beyond C and it is enlarged. It is not highly enlarged, just magnified, you can say magnified or enlarged. The image size is just slightly greater than object size. So this is point C, this is point F, it will form just beyond C. When the here object is present between C and F. Third, it is real image, and fourth, it is inverted. Okay, this is case 3. And this is case 4 actually. case 5. This is pole, this is F, this is C. So the object is at focus point. So ray will go like this, infinity. This is incident ray, this is reflected ray. Okay. So suppose another ray is going like this, and it will go, yeah, we can say one ray is going through the pole, is going like this. So the image will be formed at infinity. When object is at F, so image will be formed at infinity. They will not meet. They will meet at infinity. If we extend beyond this, they will not meet here. Not behind the or not in the front. So they will meet at infinity. This is highly enlarged. Third is, these are real. Fourth is inverted. Okay, this is the nature of the image when object is at position F. When let's consider object is at between F and P within F. So image will be formed let's consider another ray is coming like that. So it will go like that. They are diverging. Okay, so they will not meet at this side. They will meet behind the mirror. Actually, these two rays are not meeting at the front of the mirror. It is meeting at the back of the mirror. So this is behind mirror. This enlarged. This is actually these two rays, reflected rays, are not meeting. So they appear to meet at point here. Okay. So this is virtual. This is not there. Actually, rays are not meeting, and this is erect. This is the top part here. This is the biceps. So this, if this is like that, this is called erect. So this image is erect. So these are. This is case 6. This is behind mirror, and this is enlarged image. This is virtual image, and this is an erect image. Okay, so these ray diagrams are very important. The incident ray, this is incident ray going like that, and here incident ray, this is incident ray, and this is a reflect. This is a reflected ray. This is a reflected ray. This is incident ray. This is incident ray. So image is formed behind mirror, it is a virtual in nature and it is a erect and it is enlarged. It is a case 6. So these are the case for concave mirrors. I will discuss next video about concave convex mirror.